How did we get here to Wi-Fi 6E and the different types of APs that we have with no antennas to use for 6E? But in this episode, we're really going to talk about the evolution of APs, the form factor, what they look like with the different AP models that me and Francois are using. And it's really interesting to see how we're going to implement or deploy these APs because of those form factors, the size, and also fitting them into the aesthetics. And we want to talk about the different antenna APs that are available and what some vendors are doing to try to implement a directional antenna with Wi-Fi 6E access points. So I hope you enjoy this episode.
Need a Wi-Fi scanner and survey tool that won't kill your budget? Try Wi-Fi Scanner for Windows. It's an all-in-one tool to explore Wi-Fi access points, test speed, and perform active and passive surveys. Built by Wi-Fi engineers for Wi-Fi engineers. Visit wifiscanner.com to start your free trial today.
Hi, everybody. Welcome to this episode of Clear to Send. I am joined with Francois, our co-host. How are you doing, Francois?
Very good. How are you, Royal?
I'm doing great. In this episode, we're going to talk about the evolution of Wi-Fi 6E of access points going to Wi-Fi 6E. And it's going to be interesting to see where this industry goes, right? Because APs are changing. We got new frequency. Like, what are we going to be talking about here, Francois?
Yeah, so the idea came because we are, you guys have probably noticed, but the form factor of a Wi-Fi access point has evolved over the years. So we wanted to kind of, take some time to talk about this, maybe explain why is the access points form factor evolving so much, and then maybe talk about 6 GHz, some of the challenges that some of these AP manufacturers may face with 6 GHz, some of the solutions that they might come up with in relation to the form factor, and also some of the impact that it can have on the Wi-Fi design, because we'll see it. I'm just going to tease for now, but we'll see that some of these new form factor and can and features of these APs can actually have an impact on the Wi-Fi design. So we have to kind of keep that in mind as Wi-Fi engineers, and I don't think that. I think it's just the evolution, the future. So we're not gonna go back to very small APs,
No.
or maybe for some specific use cases. But it looks like it's more moving towards the AP getting bigger and bigger.
Yeah, and I think that's going to be a big challenge for a lot of us as we deal with aesthetics, especially in a campus environment where you're used to trying to hide that AP, you're using an external antenna, and that kind of poses all these challenges for us. And as we go to new frequency and adding new radios, these APs just get bigger and bigger, right? So if you try to add a lot more features, a lot more benefits to these APs, like BLE to them, or maybe you want to add, you're thinking about adding 5G radios to these, they're going to get larger. And so I don't think people will want to see them. That's just my thought. But given that we need the connectivity, we're going to have no choice, right?
Yes, you're right. And also I wanted to mention that if you're listening to this episode and audio only, we actually have a few access points that we want to showcase. So we would invite you to take a look at the YouTube video. Plus, you'll see Roa handling all of the cameras, the different camera views, like a pro.
We're gonna have to zoom out on this video just because of the AP size, but no, we'll try to make it work.
Okay, so let's start by just talking about the general form factor. If we look at most of the new Wi-Fi access points that are coming up on the market, I'm talking about the flagship access points, maybe a MIST AP45, maybe a Cisco Catalyst 9166. These access points there appear to be bigger and bigger. And if we talk about why these access points are bigger, one obvious fact is the fact that they now support 6 GHz, which means that they actually need an extra radio inside the AP to actually support that extra frequency band. Extra radio means that you need more space, you need different antennas. They'll probably have some challenges with spacing the antennas, and all of this. There's also more power required. So
Yeah.
maybe that impacts the cooling as well. I'm not too sure. I'm not like a hardware specialist, but I'm guessing that this all of these reasons gonna impact the form factor of the access points and have an influence on how big the APs are.
Yeah. More hardware going in demands more power, right? More PoE. And then the fact that we need more PoE connecting to a switch, they're thinking with this, the higher data rates, we're going to hit more bandwidth throughput through the switch. So now you need a bigger switch. That's M gig is what they're saying, right?
Yeah, the switch discussion
everything.
is the switch discussion is interesting actually, because the biggest limitation I see is power. And if you've ever had like a 6 gigahertz AP and connected it to like I'll call it a normal switch, you may have seen that sometimes the AP will tell you I don't have enough power.
Yeah.
And that's because some of these APs, they require more than PoE plus.
Yeah.
So we actually need to make sure that we have switches that can actually support more than PoE plus. So the the UPoE or the PoE plus plus. I forgot how they call it.
802.3 BT power.
BT, yeah.
You'll have even two classes of that, right? You've got what, the 60 watts and then one
And
that
the
can
90
go to
watt?
90
Yeah.
watts. Yeah.
Yeah. So you need this to have the access point operate fully. And so I've actually learned that the hard way in my lab when I got my 6 gig AP, because my switch actually doesn't support BT. So I was like, okay, so what do I do here? And eventually what I ended up doing was disabling the 2.4 radio.
Yeah.
And then adding another AP just on 2.4 in my office. I mean, it's okay here, but if you're doing like a real deployment in production, a real design, then you have to worry about these things, because that might impact your switching infrastructure.
Yeah. That might impact your budget.
Yes,
your
yes,
monetary budget, not your PoE budget, but your wallet. And I think that's part of the evolution too, is you're going to spend more money going to Wi-Fi 6E. You may be holding on to switches that are 5-7 years old that have worked with maybe 2 generations of APs that you've upgraded. But now with this new generation of access points, your budget will be a lot bigger as you try to migrate.
It's a good opportunity to migrate, I guess.
So if you need new switches, let us know. We can help you.
I was trying to see, the positive of the story, side of the story. But so, and then on top of PoE, there's one thing you mentioned, which is throughput, because in countries where, we have the 1200 megahertz available on 6 gigahertz, there's a good chance we start using 80 megahertz wide channels. So if you actually do the math on how much throughput you can get on the 80 megahertz wide channels, maybe a 40 megahertz wide channels on 5 and a 20 on 2.4, maybe you can exceed that 1 gig limit. So most of the access points now, they come with like a multi-gig port built in. But on the switch side, you also need to check if you actually need a multi-gig port or not. And like you said, if you get a switch that's BT power compatible plus multi-gig, that's when ching ching, it's expensive.
Money goes up. You're going to spend more of it. And I think maybe some of the questions in there is it really needed? And I think we'll find out pretty soon, maybe within the next year, if people are actually utilizing more than a gig on a switch port. I certainly have an environment where we do have Wi-Fi 6E with M gig switch ports, and we'll see if we're anywhere near a gig utilization at any given time. But that's all part of that evolution.
Yeah, I think if you have an environment and you're thinking of installing, deploying Wi-Fi 6 with the flagship access point, I think you're going to need the power regardless. So I think it's a good investment to get multi-gig ports as well. so you're future proof, and the switches, you can keep them for longer amount of time than the access points usually.
Yeah.
So I see that more as an investment in the future. I
Yeah.
don't think it's gonna go to waste. Yeah.
Yeah. And I don't want to stick too much on PoE, but if we talk about how some of these APs connect to a switch, not every single AP is going to require BT
Mhm.
power. I have tested an Ingenious AP, that's Wi-Fi 6E, that I have right here, and it doesn't actually need the full power, right?
Mhm.
So this one, I guess I'll show the first AP. This is the Ingenious ECW 336 tri-band AP. It doesn't need that much power. It's a 2x2 AP, but
Mhm.
it's capable of connecting to a regular PoE plus switch. But if you compare that to, say, like here's a non-Wi-Fi 6E AP, right? The Meraki MR52. This one's kind of old.
Mhm.
Just putting it up against my face, like I guess Meraki just kind of had a weird shape to it. But if
Mhm.
you compare them in size, right, it's
Mhm.
about the same size for Ingenious, which is nice. Nice form factor there.
And I guess it's just showing. I can show the couple of APs I have here. I have this one is a Cisco 9166. So if I bring my phone next to it, you'll kind of see the scale of it. So I would say it's a little wider than a regular Cisco AP. And then if we look on the side, you can see that I would say it's also a little um, thicker than usual.
Yeah.
But this is the form factor you could expect to see. Thankfully, the vendors, they try to always make sure that you can use the same brackets, and it's easy for you to replace your APs. This one is the 9166i with the integral antenna, and then I have another AP here. This one is from a company called Action Tech, and this one is compatible with the Open Wi-Fi firmware. You can see if I put them side by side, if I zoom out a little bit, it's roughly the same size,
Yeah,
but
they
the
look
access
about the same.
points, they look about the same.
The other
So
one has
there,
more of like a heat sink on the bottom.
yeah, this one has a heat sink at the bottom, and they're roughly the same weight. It's not, it's heavy. It's not light. And then I know you're going to show the ruckus. I have the ruckus here too.
Yeah.
And you can see also the ruckus is pretty big as well.
And which Ruckus model is that one?
This one is the R760.
Okay, yeah, that's the one I have too. I think by far the Ruckus is the largest, just to me. And even if I look
Yeah.
at that, like if I compare the ECW 336, right, it's tiny, it's nice
Mhm.
form factor size. It'll blend in on the ceiling pretty well. And then you've got the Ruckus. This is a big guy. Like,
Yeah.
it's huge, right? It's got the heat sink. It's a pretty powerful AP. Compare that to this in
The
size.
antennas, yeah, they have their smart antennas, right?
Yeah, it's got its the special antennas on the Ruckus, right? There's that to
Yeah.
consider. So you really got to think about the hardware. I think some of the hardware in these APs are gonna be the differentiating factor in terms of what you're gonna get. Some have their special hardware like Ruckus, whereas some of the other APs are just more of a commodity AP, where maybe the Ingenious and your, what was that other AP you had, Francois? They may be very similar in terms of hardware.
So there's one thing that can impact the hardware is the MIMO radios and the number of spatial streams they support. Because if you go down to 2x2x2, then it's going to require less power, maybe less heat, less antennas, and all of this. So you might be able to save some space and power. If you get to those flagship APs that supports 4x4 on the 5 gig, then this is when you get into the bigger form factor. And if you get 4x4 on the 6 gigahertz as well, same thing. You need more radios, you need more power, you need more antenna. Yeah.
I can show the flagship Mist AP and compare it to one of the smaller Mist APs that's tri-band. So this is the AP45, and then I have an AP24. Both are 6 gigahertz capable, but they're different in size. One of them actually has a VBLE antenna, the other one doesn't. And Francois, you were telling me earlier too with the AP24 how they're able to get it to a smaller size. Can you
Yeah. So, and then
that?
just to come back on what you were showing, like, so you guys just listening audio, you'll have an idea, but the AP45 is roughly the same size as the Cisco 9166, I would say, from the surface area. And the
And it's just as
AP24
thick
is
too.
about, it's just that thick. So it's very similar. The AP45 and then the 9166 is very similar in size and shape. The 24, the AP24 is maybe 75% smaller, so it's a smaller form factor. It actually reminds me of like an AP33. If you guys have know about that, it's roughly the same size as
it's
an
really small.
AP33.
The AP24.
Yeah. And so so what they did for the AP24 is that it does support 6 gigahertz, but it's not a it's not like a tri-band AP for the Wi-Fi. So they have like one 5 gigahertz radio, and then they have one software-defined radio, and you can choose if you want to use it as a 2.4 or as a 6 gigahertz. So you only have two radio for Wi-Fi access, and that's how they were able to kind of save room and probably power as well, compared to the 45 where you actually have three radios dedicated for Wi-Fi access,
operational simultaneously. So on the AP24, you're saying the Mist AP24, it's a tri-band AP, but only two radios can operate simultaneously.
Yeah, because you have that you know how in Mist APs they have that additional radio that does just the scanning.
Yeah.
So you would have like a third radio just to do the scanning, and then you'll have the two radios for Wi-Fi access. One would be fixed on 5 gigahertz, and the second one in your configuration, you choose if you want to use it as a 2.4 or a 6 gigahertz radio.
We'll be right back to the episode. Do you need a tool that offers seamless Wi-Fi analysis and troubleshooting? Look no further to Wi-Fi Scanner for Windows. It's a versatile 3-in-1 tool. Discover Wi-Fi access points with ease, assess speed and performance accurately, and conduct detailed active and passive Wi-Fi surveys seamlessly. It works perfectly with the internal card of your Windows device. The Wi-Fi Scanner Copilot feature is ready to troubleshoot common issues related to connectivity, performance, security, and configurations. Broaden your reach by analyzing remote networks with Optify and WLAN PI integration. Dive into beacon information or delve deeper by opening wireless PCAP files. Visit wifiscanner.com and download a free trial today.
Yeah, so that's interesting for designs is when you're looking at hardware, if you plan to use all three bands simultaneously, you want to make sure the AP can do all three. But if not, you will have to do kind of like a salt and pepper design, like 2.4 here, 5 here, 6 gigahertz here. So that might be a little bit more of an overhead to manage. But maybe the RRM algorithm can help balance that out. If it sees or detects a 6 gigahertz capable device, it could turn more of those 6 gigahertz radios on, disable 2.4. I don't know. I guess.
Yeah, my guess for this AP, my guess is, this is for environment where you don't really, or you're not really going to rely on 2.4 in the future.
Yeah.
So what you can do is you can deploy it today, have 2.4 and 5, waiting for the 6 gigahertz clients to come. And then once the 6 gigahertz clients are here, you disable 2.4, and then you just have a 5-6 network. Maybe that, that could work in like office environments where people come in with their corporate laptops.
Not so much BYOD environments, but environments where you control the hardware.
Yeah, maybe no like 2.4 IoT or like you would have to I think you would have to control the because it's probably the same for you, but I still find myself relying on 2.4 on some of the networks I work on for some devices. So I think it would be hard in some environment to just say 2.4 It's
It
not going to
will,
be
because
there.
I've run into a few enterprise environments where they did have some sort of AV piece of equipment that's on 2.4.
Hmm. Hmm. Yeah, so it's it's I don't know, maybe it's for very specific scenarios. So, but that's how they were able to kind of propose a solution where it doesn't necessarily mean as much or require as much PoE and has a
Yeah.
smaller factor. Just the fact that you have less radio.
Yeah, it could
And
be a
not
way
and
to
Yeah.
transition to Wi-Fi 6E without a
Hmm.
higher cost of going to the flagship AP. It's
Hmm.
possible you don't need the flagship AP. Maybe you don't need the BLE array built in. Like maybe
Hmm.
the Bluetooth location is not something you're going to be using.
Yeah, and another thing we saw in the maybe not so much now, but like one generation of AP ago, remember we used to have these APs that also act as like IoT hubs. I
Yeah,
remember Aruba and Ruckus were doing
Ruckus did that. Yeah.
this. Yeah. So that also impacted the form factor. Remember the
Hmm.
Aruba? I think it was a 555. It was like um, a bigger AP. Um, so and same thing. There was the same kind of principle. They were adding radios. It was not Wi-Fi radios. It was like ZigBee or BLE and stuff. But they were adding more radios to the APs, making it a more powerful device, and therefore impacting the form factor. So it's
Yeah.
kind of like the trend. More radio means it's going to be bigger. It's going to
Yeah.
require a little bit more power to operate.
Yeah.
Yeah.
So the one thing that
There's
we didn't show with APs was
Yeah.
a Wi-Fi 6E AP with an external antenna connector, right?
Yeah.
And so
Yeah.
that's where we have a challenge right now, even here in the States with the FCC. We don't have the
Yeah.
approval to use 6E outdoors, so we can't use even AP Wi-Fi 6E APs with external connectors, and that's
Hmm.
just not possible right now. We don't know. I don't know when that's going to be approved, but there are vendors coming out with a solution.
Yeah, so the problem with 6 gigahertz and external antennas is that the regulations are pretty strict when you look at the low power indoor category of devices. So they had something where they say it cannot be detachable,
Yeah.
um, but it wasn't explicitly saying that it cannot be external. So some vendor came up with some solution where you could actually use an external antenna, connect it, but never disconnect it. So you have like a very specific process of gluing and screwing the antenna the first time around, so you're not able to actually disconnect it in the future. Um, but that's that you can actually do that in Canada today. But in some countries like in the US, some people push back and they're like, okay, wait, they're not playing fair, and so the US said, okay, we'll we'll hold off on this and we'll see what we do in the future. Um,
So you're saying
but the future,
in Canada,
yeah,
you can have an external antenna like separately from
yeah,
the AP, but it's
yeah,
connected to the AP, but cannot be, you're not able to
yeah.
disconnect it from the connector.
Yeah, there's this
Okay.
AP from Mist. It's called the AP45E, and you can. They have a special connector as well, so you need to look at. Be careful about which antenna you want to use, but you can buy an external antenna from Axel Tech, for instance, that will let you connect it and get 6 gigahertz with external antenna. And when they have a procedure like a PDF document that shows you how you're supposed to connect everything to comply with the regulations.
Okay.
Yeah.
And
Yeah.
there is another AP that you were telling me about. And actually, I had a discussion with a university here in San
Hmm.
Diego. They were testing this AP as well. And they're telling me it's got some directionality. It's a Wi-Fi
Yeah.
6E AP. What do you know
Yeah.
about that as
Because
well?
So the thing is, if you want to, if you want to comply with the standards and use external antennas, then you have to look at standard power APs. But standard power APs means that you also have to comply with the AFC. And as you know, AFC is not
That's not,
really in
it's
place
not fully
yet.
baked yet.
It's not fully baked yet, and then it also require the access points to talk to an AFC provider and more stuff we don't control, and all of this. So it's not really like the a viable option today. So what vendors starting doing is looking at integrating directional antennas inside the access point, right? So we could actually come up with a solution with an access point, being low power indoor with directional signal on 6 gigahertz, right? Which it's a good idea if you need directional antennas indoor. Obviously, that won't work outdoor, but for indoor solutions, it's a good idea. And Cisco, they came out with this AP. Actually, Cisco, they were doing it for outdoor. They've been doing it for a couple of generations. For
Yeah.
Wi-Fi 6, they have this AP called the 9124D
Mhm.
that you can actually get, and it has like a directional antenna built into it.
Yeah.
They also have like a 9104, I believe. It's like an antenna that has multiple
Oh,
radios,
yeah.
or
I've seen that one.
it,
And I've used the
yeah,
older APs, the 1562D. It's an outdoor AP with some directionality to it built in.
yeah. And you can even change, like they have this antenna where you can change the beam width
Mhm.
based on what you need. This is more for like, public venues,
Yeah.
large public venues. But anyway, for this 6 gigahertz, they came up with this antenna. It's called the 9166D1. I think that's the official name. And so what they did is they took an external antenna, something that would give you a beam width similar to the 9166 P4, if you guys are familiar with that one from Cisco. But it's pretty much like I think it's like a 90-degree beam width, horizontally speaking, and it gives you that pattern, but it's built into the
Yeah.
AP. So now you don't
It's
have to worry about regulations.
one solid piece of hardware, right?
It's one. It looks like, I'm. It's too bad that we're recording this because I'm supposed to get one today. But it kind of looks like the 9166, but it actually has a direction to it, and it comes with like a bracket that you can actually use to orient the AP
Articulate
in
it.
different orientations. Yeah, tilt
Okay.
the AP in different orientations.
Okay.
And let me just validate the antenna patterns because I have it here.
Yeah.
For the
And that's an
91s.
interesting AP model because now it kind of goes it's like trying to bend to the FCC rules, right? It's pretty much integrated into the AP, but instead of
Yeah.
being omnidirectional, it's like building in a patch antenna into the AP itself. And then you need to articulate the
Yeah.
whole AP.
You're not really bending the rules at this point. You're,
Working
I
around
would
them
say,
somehow.
yeah, I would say it's,
It's still within the rules. It's
respecting.
just finding a way to work with the rules and get a solution out of it where people may not want omnidirectional. They want to focus that 6E signal. And so building that into the antenna, which just gets built into the AP, you can't remove the antenna at all. So that doesn't break any of the rules that are currently in place.
So I think the genius in this is that it's one piece of equipment, so it's easier to manage, easier to install, as long as the installer knows it's directional, so it installs properly. And the form factor is also better looking. Hopefully, I don't know. We'll see how
Yeah.
that plays
But is it
in the
bigger?
field.
It's a much larger AP, right?
I don't know. I
I
have
guess
to
you'll
compare.
find out
Maybe
when you
we'll
get it.
yeah, when we get it, well, I'll take pictures and then we can put it in the show notes.
Yeah. I was
but-
told by the engineers at this university that it's a large AP.
Okay. So we'll confirm this. And then, but the drawback is that you don't really choose the directional antenna, because with external antennas, we are used to have the flexibility and the luxury to change and use the antenna that fits the job. In this case, what you get is what you have in the AP, and I have the beam width. It's a 60 by 60 on
Okay.
on 6 gigahertz, and it's an 8 dBi gain, right? So it's
Okay.
pretty nice. On 5 gigahertz, it's 70 by 70 with a 6 dBi gain, and 2.4 same thing, 70 by 70 and with a 6 dBi gain. So you have, it's pretty good. I mean, for the beam width, that's probably what you want if you have an environment where you need something more directional. Like I think about universities, it could actually be a very good use case for universities.
Yeah. Large lecture halls, high density areas indoors. That's where they'll want to use it and try to take advantage of 6 gigahertz.
Yeah,
But that,
or
yeah,
even that I don't know, maybe warehouses. You still indoor, and sometimes you need the
yeah.
directionality. So that could be a good use case as well.
Assuming those
So
old scanners get upgraded to 6 gigahertz.
wow, no, in the
It's a
future we'll
different
have
discussion.
robots. We won't have
We,
scanners. We'll have robots.
well, yeah, we'll have robots now. Maybe we'll have a
Yeah.
separate episode on the evolution of client devices. But it's
Yeah.
interesting to see the types of APs that we're seeing, the form factors, how they'll fit in with aesthetics. Because I don't know, aesthetics always seems to be popping up as a more and more important topic when it comes to design in a
Hmm.
lot of the buildings that I'm involved with. But surprisingly, too, like I have quite a bit of 6E access points, which is I didn't even realize I had that many just sitting here, and some of them I haven't powered on yet. Like the AP24, I haven't plugged in yet. I just got it recently, and I think I do want to test out that software defined radio and really see how it operates, because that'll impact too. I could see some users selecting the AP24 because maybe it costs less than a AP 45, and not knowing
Hmm.
that you can't operate all three bands
Hmm.
simultaneously. But also just seeing form factor is what people tend to go with. So we'll
Hmm.
see, like even with the next generation of Wi-Fi, does that impact the size at all? Will we see something different? Um, but that's where we're
I'm
at
really
currently.
hoping for. Yeah, I was gonna say I'm really hoping for vendors to innovate in their APs. I really like the fact that Cisco came up with that directional antenna AP built in. I hope other vendors will ride the wave of this, because I think it can be very beneficial
Hmm.
for people. Even if they can come up with a technology where you can change the beam width of the antenna.
Yeah.
I don't know if it's possible technically, but it would be really really useful for people in the field.
Yeah, I'd be curious if other vendors start implementing that, unless one of these vendors has a patent on it. Like I don't know if Cisco has a patent
Hmm.
on that type of antenna, kind of like how Ruckus has a patent on their specialized antenna.
Hmm.
So we'll see how where this industry goes. Of course, I think as vendors become really creative, they'll want to keep that as their special like differentiator, their special sauce, and how people start to pick which vendor they go with. Maybe that's why we don't
Hmm.
see too many of the integrated antenna directional. And
Hmm.
I've only really seen that with Cisco.
Hmm. Yeah. Well, we'll see. Because 6 gigahertz is definitely a challenge if you want to use directional antennas today. So
Yeah. Today it's going to be a challenge. I don't know how long that challenge will stick around. I'm hoping maybe next year we have information on using AFC, which then we can use standard power APs and directional
hmm.
antennas. But maybe that's the next part of that evolution. It's like we're gonna have 3 parts to Wi-Fi 6, right? We got Wi-Fi 6, Wi-Fi 6E, and then we got the standard power with Wi-Fi 6E coming out. Um, so
Hmm.
3 phases of this, and then we're gonna next we'll be talking about Wi-Fi 7 by the time AFC is done. But
Yes.
yeah, well, I'm
Awesome. So
interested
I
to know
think I
what you
think we
guys.
covered. Yeah.
I'm just interested to see what others have to say as well. So if they can provide like their feedback on Twitter or also on the comment section of this episode, that would be interesting.
You can send your AP beauty shots, and we can compare all of the beauty form factors.
But I want to thank you guys for listening. Uh, Let us know what you guys think, what you guys want to hear about, and we'll see you guys on the next episode.
Thank you, guys. See ya.
Need a Wi-Fi scanner and survey tool that won't kill your budget? Try Wi-Fi Scanner for Windows. It's an all-in-one tool to explore Wi-Fi access points, test speed, and perform active and passive surveys. Built by Wi-Fi engineers for Wi-Fi engineers. Visit wifiscanner.com to start your free trial today.